I want to do one last example of implicit differentiation. This is going to tie together a couple different concepts that we've covered in the recent past, and I want to do it at speed a little bit so that you can kind of get a sense for how well it goes. And then I want to wrap up the video by sharing with you the Mark patent shortcut technique. This is something that Mark came up with last year, and it was like, well, wow, that took away a couple steps of algebra, made it less likely that you would make an algebra mistake along the way. So a lot to go through. Let's take a look at what we've got. All right, so the problem is that we want to find the equation of the line tangent to negative 36 is equal to negative 7y squared plus 9xy minus 6y minus 8x squared at the point 2 comma 2. So 2 comma 2 is a point on this curve, and we want to know what the equation of the line that goes through that point and is tangent to that curve. So we've done this problems like this in the recent past. We can use the point slope method. We know a point that's on the line, but we need to find the slope, and the slope is going to be the derivative of this curve at this point. So since there are x's and y's combined here, and it would be impossible to think about putting the y on one side and then all of everything else on the other side. So we're going to use implicit differentiation. When we take the derivative of both sides of the equation, negative 36 is a constant, so that's just going to become 0. And that's equal to negative 7y squared. That's in terms of y. So that is going to be negative 14y times dy dx. Actually, let me take out dy dx, something that you might enjoy doing that just kind of gives you a little bit less writing to do is just to use y prime, okay, the derivative of y with respect to x. All right, plus 9xy, we're going to use the product rule for that. So the first thing we do is we do the derivative of the first part and then the second part. So the derivative of 9x is 9, and then the second part. And then we add the first part times the derivative of the second part. So the first part is 9x, and the second part is the derivative of y, which is y prime. Go on, negative 6y. The derivative of that is minus 6y prime minus 8x squared. That's totally in terms of x. So that is just going to be, we just use the power rule for that. So that becomes 16x. Okay? So now we want to solve all of this for y prime. So the first thing we'll do is everything that doesn't have a y prime in it, we'll move over to the other side. So we'll move that over to the other side. So that'll become 9y. We'll move this over to the other side. So that becomes plus 16x is equal to negative 14 y prime plus 9xy prime minus 6y prime. Okay, the next thing we do is we can factor a y prime out of this times negative 14y plus 9x minus 6. And the last thing we need to do to solve for y prime is we just divide here. So our numerator is going to be negative 9y plus 16x, and our denominator is going to be negative 14y plus 9x minus 6. All right, so this gives us the derivative of the function at any point xy that's on the curve. We're interested in that derivative when x and y are 2 and 2. So we have x equals 2 and y equals 2. We'll substitute it into here. So we've got negative 9 times 2, which is negative 18, plus 16 times 2, which is plus 32, over negative 14 times 2, which is negative 28. 9 times 2 is 18 minus 6. All right, and so we do a little arithmetic. Negative 18, 32 minus 18 is positive 14. Negative 28 plus 18 is negative 10. Negative 10 minus 6 is negative 16. And so we can simplify that, and so our derivative becomes negative 7 over 8. Okay, so that gives us the derivative of this, which gives us the slope of the line that's tangent to this curve at 2, 2. So in order to find the equation of the line, all we need to do is to just substitute x and y and m into the point slope formula. Remember, y minus y1 is equal to m times x minus x1. So our x1 and y1 are 2 and 2, so that's y minus 2. M is the slope of the line, which is negative 7 over 8, and then we've got x minus 2. So that is a perfectly fine way. I have given an equation of the line that's tangent to that curve at that point. I don't need to turn this into point slope form. If I do, there's a chance I might make some mistake, and so I don't want to do that. So there is the answer to my question. Now, as I said before, I can show you a shortcut technique that Mark Patton came up with last year. And that is that he stopped at this point and said, well, I don't need to solve this for y prime. I'm not really interested in finding this answer. I'm interested in finding this answer. This is what I'm looking for. So instead of substituting x equals 2 and y equals 2 into the equation at this point, why don't we substitute it into the equation up at this point? So let's see what happens when we do that. So that becomes 0 is equal to negative 14y, which is negative 28 y prime, plus 9y, which is 18, plus 9x times y prime. So 9x is 18 y prime, minus 6y prime, minus 16x, which is minus 32. Okay, so at this point, now we can combine like terms. So negative 28y prime plus 18y prime is equal to negative 10y prime, minus 6y prime is negative 16y prime, and then 18 minus 32 is negative 14. So to solve this equation for y prime, first thing we do is we add 14 to both sides, negative 16y prime, and then we divide both sides by negative 16, 14 over negative 16, which again simplifies to negative 7 over 8. So what we did is we replaced all of this work with lots of x's and y's in here to make all sorts of potential mistakes, and we just replaced it with just 4 lines of work instead of 1, 2, 3, 4, 5, 6, 7 kind of lines of work. So I really appreciated that because it just makes it less likely that you're going to make a mistake combining your x's and y's to form that equation right there. Since, as I say, if you're not being asked to find that equation, if you're just asked to find the slope at a specific point, you may as well substitute that number in early. So that gives you an idea of how to do a harder problem, how to find the equation of a line using the point slope formula like we've done in the past, and how the Mark Patton technique can kind of shorten your work and make it slightly less likely that you're going to make an algebra mistake along the way.